Hello everyone. Our today's revision topic is qualitative analysis. As the name it is, qualitative analysis means that we are going to detect the elements, and we should be very precise with the topic that what are the relevant questions that can be asked or that are useful from this topic, because it's an experimental thing that there are, when you read the books you will get lot of information from the apparatus to the information given in terms of reaction. So I'll suggest you that as per the importance of the topic you should give the time, allot your time accordingly. So starting with the first part, that is the detection of which elements, carbon and hydrogen, because we know we are talking this topic in organic, and which is carbon, hydrogen is there, along with them some other elements like nitrogen, sulphur, halogen, phosphorus, they can also be present. So starting with the detection of carbon and hydrogen. Now this can be carbon and hydrogen can be detected by heating with cupric oxide. How? With carbon, when treated with or heated with cupric oxide, it oxidizes carbon to CO2. And when how we detect CO2 is there, we pass it through lime water solution, which turns lime water milky, and that is the indication that CO2 is evolved or CO2 is evolved, that means carbon is present. Similarly, hydrogen can be detected by heating with cupric oxide, and then it gives H2O. This H2O can be detected by using anhydrous copper sulfate, which is white, and after water molecules combine with it, it forms copper sulfate pentahydrate, which is blue in color. Okay. Then next is detection of nitrogen, sulfur and halogens. So here we can detect them by using which test? Lysine test. And what we prepare? We prepare lysine extract. Now in this experiment of lysine test, what we take? We take ignition tube. In that we put small size, pea size sodium metal and heat it so that sodium metal converted to a shiny globule. Then we put small amount of mixture, organic substance or organic compound which we have. We put this small mixture in the ignition tube, heat the ignition tube till it becomes red hot, and then we put this ignition tube in the china dish in which distilled water is there. Quickly it bursts, and the compound which contains nitrogen, sulfur or halogen, when they react with sodium metal, they convert from their covalent form to the ionic form, and from that fused mass, by using distilled water, we prepare extract which is known as sodium fusion extract or lysine extract. So by treating with sodium metal, we convert them from covalent form to their ionic forms, like here in the first one, carbon, nitrogen, when treated with that sodium metal they form Cn minus. So if sulfur is there, it forms sulfide. Halogen is present, it forms halide, and this fused mass we extract by using distilled water. Okay, then we take that sodium fusion extract or lysine extract in the test tube and start testing for nitrogen or sulfur or halogens. So first is the test for nitrogen. Now I hope that when you are going through that part, your notes as well as your NCERT book, most important is NCERT book, because you have written some points in NCERT book, that is ready, so that you can read that part simultaneously. During the lecture you can pause this lecture, or after this lecture you can again read those points. In testing for nitrogen, we take ferrous sulfate with Cn minus, it is in the form of NaCN. It combines with it and forms hexacyanidopherrate. If it is given in the neutral form, that must be Na4, because it is 4 minus, right? So ferrous sulfate we take, and then we treat it with our lysine extract which contains Cn minus, and when they react it forms hexacyanidopherrate. Now by addition of H2SO4, some of the Fe+2 ions oxidize to Fe+3, and these Fe+3 ions combine with the hexacyanopherrate in this form, and finally gives Fe4 FeCN6 whole thrice dot XH2O, ferrocyanide, which is important part in this reaction is after treating with ferrous sulfate, and finally it gives a Persian blue color compound. Its formula is important, Fe4 FeCN6. In that one Fe is +3 and here Fe is +2. Okay, so this is the test about nitrogen, which is giving a Persian blue color. Then important point is that this test is not given by hydrazine or ammonium chloride or ammonium nitrate or hydroxylamine or diazonium salt or diazo compounds. Why it is not given by these? Because they contain nitrogen but not carbon, and we know to test the nitrogen we have started with which ion? Therefore these compounds, although they contain nitrogen, but they do not give test for nitrogen, like they won't give Persian blue color. Okay, then other information is that diazonium salt also won't give this test, and diazo compounds also do not give this test because N2 gases evolved easily. Okay, so that is the information for test for nitrogen. Now next is test for sulfur. In this test, the lysine extract, we take lysine extract, acidify it with acetic acid, and then few drops of lead acetate is added. This gives black PPT of PBS plus salt of acetic acid is given. Now in this case we acidify the solution with acetic acid. In case we use H2SO4, or why we do not use H2SO4? Because when we acidify this solution with H2SO4, then lead acetate reacts with H2SO4 and it gives white precipitate of PbSO4, and this white precipitate interferes with the test. So that is why we take acetic acid to acidify the solution, and this test is known as lead acetate test. Now next test, which is very important, just like in nitrogen we have done Persian blue color is there. This is test for sulfur, and very important test, which is sodium nitroprusside test. So generally lysine extract plus sodium nitroprusside resulting into a violet colored complex formation. That is the test for sulfur, important test, which is sodium nitroprusside test. Now reactions involved, we take lysine extract, which is containing the Na2S, with this compound which is sodium nitroprusside. In this Fe is in +2 state, NO is overall +1. Then again here after the reaction, this complex is formed FeCN5, NOS, and violet colored compound is there. Now remember one thing, it is charged with 4-. If in the question it is given neutral form, then we put there Na4. Clear? So when we add sodium nitroprusside, then finally we get violet colored compound. Solution becomes violet colored. Then the point is, if both nitrogen and sulfur are present, in that case this type of sodium thiocyanate is formed, and then with Fe +3 plus HCN minus gives a blood red coloration, which indicates that both nitrogen and sulfur are present in the given organic compounds. Right, this is purely NCERT reaction I am writing here. In NCERT that is given. Now another point is, which is something little bit extra, that if another way is that sodium thiocyanate formed, then we add little bit of dilute HCl, and then we add FeCl3, ferric chloride. It gives two reactions are given. One is FeSCN thrice. Another is compound is that one, FeSCN with 5H2O. They both are mentioned as blood red color. They both are given blood red. So I'll say that important is NCERT reaction, that is FeSCN, overall charge Fe +2, Fe is +3 here. Okay, if any information is given that these both are given, that these are compounds formed, then they both are mentioned as blood red, reason for the blood red coloration. Now more important is FeCN thrice, which is also mentioned in NCERT. Clear? Now next is test for halogens. In halogens, lysine extract is acidify with HNO3, boil it, then we add few drops of AgNO3 solution, and then we add ammonium hydroxide. This is the general way. Now, what is the use of acidifying it with HNO3? If our lysine extract, if you remember, there are ions possible like Cn minus or sulfide ion or halide ion. So right now we are testing for halide ions. If nitrogen and sulfur are present, then they will go into their corresponding ions, cyanide and sulfides, and that will interfere with the test. These ions will also interfere with the test. So firstly we remove them by using which one? That treating with HNO3. HNO3 reacts with cyanide ion to give HCN gas. With sodium sulfide, it gives H2S gas. That means other elements like nitrogen and sulfur, they are removed by using HNO3, converting them into or decomposing them into HCN gas and H2S gas. Right? If they are not decomposed, then AgCN will give precipitate, which is white precipitate, and Ag2S will form, which gives black precipitate. So that is the use of treating with nitric acid. Then after removing them, we add silver solution, silver nitrate solution. If NaCl is present, then AgCl white precipitate form, and this precipitate is soluble in ammonium hydroxide solution. If NaBr is there, AgBr pale yellow precipitate is formed, and this is partially soluble in ammonium hydroxide, and byproducts are same, NaNO3. If NaI is present, then it will form dark yellow precipitate, and this is insoluble in ammonium hydroxide solution. Okay, so this is the test given in NCERT. Now two terms I am mentioning here. One is layer test, where we add chlorine water, and other is Bilstein's test. In Bilstein's test, only name you can remember because tests are not given in NCERT. So in this test, a particular green color flame is there. Complete copper wire we take and complete process is there. So important is only if you solve any questions on that and you get Bilstein's test or layer test name, then by name remember that these are the tests for the halogens. Like in layer test, we use it when the given organic compound contains more than one type of halogen. If it contains more than one type of halogen, then we do not use or this test is not suitable, which is silver nitrate solution added. Then we use layer test, but it is not given in NCERT. So only thing which you can use here is the name layer test for halogen or Bilstein's test for halogen. The next is test for phosphorus. Now in this test, organic compound which contains phosphorus is heated with oxidizing agent, that is Na2O2. After this it converts it into its phosphate, Na3PO4 plus Na2O. Now in this phosphate we add water, extract it, filter it, and in the filtrate what is added? Nitric acid. This forms H3PO4 and byproducts are there. Then we add ammonium molybdate in this solution, and after adding ammonium molybdate, we get a yellow precipitate of ammonium phosphomolybdate. These are reactions written in NCERT. Also you will get the reactions there. It is given in balanced form, so you can go through that part. Here I am only writing the products, that after this formation of H3PO4, adding ammonium molybdate, it gives a yellow precipitate of this compound, which is NH4 thrice PO4 dot 12MOO3. It is yellow color or yellow precipitate. Other are the byproducts. So this is a test for phosphorus, in which we are taking organic compound which contains phosphorus and heating it with oxidizing agent. We are not preparing its lysine extract. Okay, lysine extract we have prepared for testing nitrogen, for testing sulfur, for testing halogens. Okay. Hello students, in our today's revision topic we are going to talk about the quantitative analysis. Last topic we covered was the qualitative, in which we discussed about the identification of the elements like carbon, hydrogen, nitrogen, sulfur, halogen and phosphorus. Now today we will talk about how to find the percentage of the particular elements. Okay, it's a revision topic, so we should focus only on the most relevant part of the particular estimation of the element, because this is a purely experimental thing that complete setup is given, colorful diagrams are given, you can go through that part, but at the end you should utilize the time in solving a particular type of questions that are useful for the final exam. Clear? So first part is the estimation of carbon and hydrogen. Now this is done by a method which is the Leibig's combustion method. In that case, I am not writing any balanced equation because it is already given in NCERT. When you revise completely. Here I am only using the information that organic compound is heated with copper oxide, Cu in +2, copper oxide in excess of oxygen, it gives H2O and CO2. Now there is a complete setup given, you can go through that part in NCERT, and then we identify the mass of water. Finally, in short, I am telling mass of water by using anhydrous calcium chloride or it is anhydrous magnesium perchlorate. So whatever is the mass increase in these compounds, either CaCl2 or MgClO4 twice, then we get the mass of water. From that mass of water we can find out the mass of percentage of hydrogen. Similarly, CO2 we get through the potassium hydroxide. It is absorbed in the potassium hydroxide solution. Whatever mass is increased, from there we get the mass of CO2, and if we have mass of CO2 we can easily find the percentage of carbon in the given organic compound. So only relevant, very precise information for H2O, it is absorbed in the anhydrous this substance or CO2 absorbed in this, that is KOH. Now what is the formula for finding percentage of carbon in the organic compound? It is, because we know the mass of CO2. Now if we have mass of CO2 we can find the moles of CO2. Given mass upon molar mass of CO2, this gives moles of carbon dioxide. And if we have the moles of carbon dioxide, we use simple mole concept. Whatever are the moles of carbon dioxide will also be the moles of carbon. So this part is also equal to moles of carbon, and if we have moles of carbon multiply by the atomic mass of carbon, we get mass of carbon. So multiply this mole into 12, and this term completely becomes what? Mass of carbon divided by mass of the organic compound into 100. So and other part is 12 by 44 because it is fixed. 12 upon 44 into mass of CO2 which is given in the numerical, mass of organic compound given in numerical into 100. So this is the formula to find the percentage of carbon. So what we use? Pure simple basic mole concept we are using, that if you have mass of CO2, find out moles of CO2. If you have moles of CO2, these are also moles of carbon, and if you have carbon moles, then multiply by its atomic mass to get the mass of carbon. That means numerator will be there, denominator is given in the question, which is weight of organic compound. Similarly, for finding percentage of hydrogen, we use this formula, which is mass of H2O. We know experimentally it is given in the numerical, mass upon molar mass will be number of moles of H2O. If we have moles of H2O, the number of moles of hydrogen will be exactly twice. So that part is multiplied by 2 and multiplied by 1, which is the atomic mass of hydrogen. So this complete term is mass of hydrogen divided by weight of or mass of organic compound into 100. So this is the method for estimation of carbon and hydrogen. Now here this is not that important, but yes, it is given, so you can go through that part completely. The important is next one, which is estimation of nitrogen. For nitrogen we use first which method? It is Duma's method, very important method, Duma's method, and the important part is their numericals. So firstly a general outline about this one. Organic compound is heated with copper oxide, it is copper in +2, in the atmosphere of carbon dioxide. this organic compound is containing nitrogen, right? Now the nitrogen finally comes out as N2, and from this N2 we will estimate the percentage of nitrogen in the given organic compound, right? So in short, by doing this method we are getting the nitrogen in which form? In N2 form, N2 gas, plus byproducts Cu plus H2O plus CO2 plus SO2, other gases are also formed. So in NCERT complete balance equation is given, you can go through that one also. Here we are using the information that is important for us is N2 gas is evolved. Now this is then collected over a complete setup is given, collected over a solution of KOH. The KOH absorbs CO2, it absorbs SO2, it absorbs water vapor, everything. So N2 gas is collected, right? Now from that N2 gas we will finally reach up to which point? To find out the weight of nitrogen. And if we have weight of nitrogen, divide by the weight of organic compound into 100 will be the percentage of nitrogen. So in short, in Dumas method we are using nitrogen percentage from N2, right? Now simple formula we can find out nitrogen moles we have in the question. Nitrogen moles we can find out, or we can use this percentage of nitrogen. We can use the formula that number of moles of nitrogen, whatever are the moles of nitrogen, multiply by 2. These will be the moles of nitrogen, single N. I am not talking about N2, I am saying single N moles will be getting from moles of N2. And where number of moles of N2 into 2, this part is number of moles of single nitrogen. If we have number of moles of nitrogen multiply by its atomic mass, then this part becomes what? Weight of nitrogen divide by weight of organic compound into 100. Ultimately we will use the data given in the numerical. So firstly we convert that number of moles of N2, finding out how? By using the equation PV upon RT. Now this pressure is pressure of N2, because in the question if you see, generally in Dumas method they give moist N2. That means pressure of N2 is there plus pressure of water vapor is there. That is, you can see if it is not given, then we can directly take it is as pressure of nitrogen gas, and if it is mentioned moist N2 or aqueous tension is given, then we subtract the net pressure from the aqueous tension value. We will do that example. So here number of moles of N2, we put here what? PV by RT, where P is pressure of N2 gas, volume generally in ml, so we can divide it by 1000 later on, upon R 0.0821. Temperature conditions are mentioned in the numerical. This part is number of moles of N2 into 28 upon weight of organic compound into 100. That is the formula, basic formula to find the percentage of N as per Dumas method. Like one example, NCERT example, it is that weight of the organic compound is 0.3 grams, volume of N2 evolved 50 ml, at which temperature? At 300 Kelvin, total pressure is given 715 mm of Hg, and in the numerical it is given in brackets aqueous tension. So pressure of H2O is 15 mm at 300 Kelvin. That is the data given. Now if that information is given and clearly we know that Dumas method is mentioned, so we use this formula directly, which is partial pressure of N2 subtracting this value, because we want only pressure of N2, that means it is 700. It is mm of Hg, so we divide it by 760. This part is pressure of N2. Volume, it is 50 ml divided by 1000. This will be your volume term. R 0.0821 or 1 by 12, approximately 0.0821. Temperature is 300 Kelvin into 2800 we can do upon weight of the organic compound, which is 0.3 grams. Now this is one method. In NCERT they have given one method in terms of volume of N2 at STP. You can use that formula also, you can use that one also, and you will get approximately same answer, right? So by using that one also you will get the percentage of nitrogen using Dumas method. Now next method is Kjeldahl method. In this method, organic compound is heated with H2SO4. In NCERT you can see H2SO4 is given in the diagram, and there it is mentioned CuSO4 also, right? CuSO4 is also mentioned. So I will mention what are the points, other information. Organic compound heated with H2SO4. This organic compound which contains nitrogen. This nitrogen after treatment with H2SO4 gives ammonium sulfate. This ammonium sulfate then treated with excess of NaOH, and after treating with excess of NaOH, it evolves gas which is ammonia. We are basically trying to find out the percentage of nitrogen in the organic compound. So firstly, organic compound which contains nitrogen after treatment with H2SO4 gives ammonium sulfate, that is converted into ammonium sulfate, and from there we treat it with NaOH. This nitrogen then goes to ammonia, that is ammonia evolved. Byproducts are mentioned there. Now this ammonia is treated with or is absorbed with standard solution of H2SO4. Standard solution of H2SO4, that means we know its concentration, and acid base reaction takes place, and then we finally get the percentage of nitrogen by estimating the amount of H2SO4 reacted with ammonia. How? This is the formula given. Now some important points like CuSO4 which we add in H2SO4, even in NCERT you can see in the diagram it is given, it is acting as a catalyst, right? Then K2SO4 is also given in experiments, that it is also added to increase the boiling point of H2SO4. So this is additional information you can mention in your notes or in NCERT directly. Then in short we can say, in Kjeldahl method, nitrogen from the organic compound is converted to ammonium sulfate, which finally comes out as which gas? Ammonia. Whereas in Duma's method, finally N comes out as nitrogen gas, N2 gas, and here nitrogen is coming out as finally ammonia. So we will use ammonia to find out the percentage of N, and this ammonia amount or its details we will get from the standard solution of H2SO4 that reacts with ammonia, because we know whatever are the equivalents of acid will also be the equivalents of base, and we know the concentration of H2SO4 solution which we are using. So starting with the formula, percentage of nitrogen in the compound will be mass of nitrogen upon mass of the organic compound into 100. Now mass of nitrogen we can use what? Whatever are the moles of nitrogen, whatever are the moles of ammonia will also be the moles of nitrogen, that is single N. So number of moles of ammonia will also be number of moles of N, and if we have moles of N multiplied by the atomic mass of nitrogen, which is 14, so this term is basically what? Mass of nitrogen, right? Now we will put some more things there. Number of moles of ammonia is also equal to equivalents of ammonia because N factor is 1. So here I am putting only equivalents of ammonia upon remaining terms same. Now whatever are the equivalents of ammonia will also be the equivalents of H2SO4 that reacted with ammonia, because H2SO4 standard solution we are taking, right? Now in the numerical, either excess of H2SO4 is used, then some slight difference is there in the usage. Otherwise, if directly it is given that H2SO4 is reacted with ammonia, then it is very simple question. Simply find out the equivalents of H2SO4 by using the mole concept. You know the formula of how to find equivalents, that is normality into volume or molarity into normality into volume is the formula for number of equivalents. Now equivalents of H2SO4 reacted to ammonia upon weight of the organic compound, remaining terms same, 14 into 100, right? Now in this case, if in the numerical, I am purely talking in terms of the questions that are asked from this method, right? One is that H2SO4 is given, and it is given that whatever it is reacting with ammonia, directly given. So we will directly multiply normality of H2SO4 into volume, N1 and into V, this is also equal to equivalents of ammonia. So put this value, divide by the weight of the organic compound into 14 into 100, that is 14 and 100, that is coming from the beginning. Now if the question is giving uh, excess of acid used. Although excess of acid we use, but again it depends on the numerical. If excess of acid is used, then what happens? Firstly, H2SO4 reacts with ammonia. Ammonia gets consumed, right? But excess of acid is there, so we neutralize this acid by using base, that is NaOH. So in short, the H2SO4, it all depends on the numerical how it is framed. If it is framed, it is using excess of acid, that means excess of H2SO4 given, standard concentration is given, normality given, volume given. Now this H2SO4 reacts with ammonia as well as excess of acid which is left after reacting with ammonia, H2SO4, it is further treated with NaOH, right? Now suppose there are 100, we have decided by the normality into volume term, suppose 100 is the value of the H2SO4 equivalents. Now some of the equivalents reacted with ammonia. For us the only part relevant is what are the equivalents of H2SO4 reacted with ammonia. We want to find out that one, right? But we do not know why, because excess of acid is taken. So what we are going to do, firstly from the using the total concentration and volume given, we find the total equivalents of H2SO4. Total equivalents, suppose 100. Some reacted with ammonia, suppose X equivalents reacted with ammonia. Now in the numerical, if NaOH is given, that means its volume as well as its concentration is also given. Now we can find out that whatever are the equivalents of NaOH, that is base, will also be the equivalents of H2SO4, which is reacting, excess of acid reacting with the NaOH. Suppose this is coming out to be 70, this is total 100 and we find out that is around 70, so that means that total 100, 70 reacts with NaOH and 30 which is remaining is reacting with ammonia. This 30 we will put here and then find out the final answer. So we'll do the numerical on that, but the important point is that we have to find the equivalents of H2SO4 react with ammonia finally. If excess of acid is given, then we find out the total equivalents of H2SO4 minus the equivalents of base, that is NaOH. This subtraction will give the equivalents of ammonia which reacted with H2SO4. Okay? Now see the formula here. After this, putting their milli equivalents of H2SO4 react with ammonia. Why milli equivalents? Because mostly we use volume in ml and normality. So volume in ml means we divide by 1000. The milli equivalents of H2SO4 divided by 1000 into 14 upon weight of organic compound into 100. That is the formula you can use to find the percentage of N as per Kjeldahl method. Now next formula which is given in NCERT is, so you can use just like Duma's method, one more formula is given in NCERT, you can go through that one also. You should know these formula are given. If any question is directly asked which is the correct expression, so that time you should remember that this is the expression given in NCERT, like this is given in NCERT, 1.4 into normality of the acid used into volume of the acid taken upon weight of the organic compound. That is the formula, which is normality of H2SO4 used and this is volume of the H2SO4 reacted with ammonia. Okay, that is the formula for percentage of nitrogen. Now next is a numerical, which is on the method which is Kjeldahl method. Now in this case, weight of the organic compound is given, which is 0.5 grams, and the ammonia evolved is treated with H2SO4, and how much H2SO4 given, that is 10 ml of H2SO4, which is 1 molar. That means only that information is given which we can infer that excess of acid or NaOH is not given. So why should we consider any other formula? We simply consider milli equivalents of H2SO4 reacted with ammonia. So here milli equivalents means its molarity given. So we can convert it into normality, which is multiplied by 2. Number of equivalents will be normality into volume, milli equivalents upon 1000. Which formula I am using? Directly that one. Milliequivalents of H2SO4 react with ammonia. Normality into volume upon 1000 into 14 into 100 divided by weight of the organic compound, which is given 0.5 grams. Now that is the basic formula which you can use, but main thing is that you understand that part, that it is the equivalents of H2SO4 reacted with ammonia. So in the this NCERT numerical, directly I am using the formula, you will get the exact answer, right? Then next question is where we use excess of acid. What is the question? In this method, Kjeldahl method, organic compound is having mass 0.2 grams, H2SO4 n by 5 normal, 1 by 5 normal, and 60 ml is used in this reaction. Now another information given in that question is excess of acid is neutralized by 40 ml of n by 10 NaOH. Now tell me, if excess information is given, we have to find out ultimately what? The number of milliequivalents of ammonia reacted with H2SO4, or we can say milliequivalents of H2SO4 reacted with ammonia. So here total equivalents of H2SO4 will be 1 by 5 into 60. 1 by 5 into 60, that means 12 milliequivalents total of H2SO4, right? These total are used for ammonia, and they are also used, excess used for NaOH. Now we know that this amount is neutralized by this one as well as this one. This value is 40 into 1 by 10, that is 4 milliequivalents. Getting that one, this is 4 milliequivalents. Now 12 total minus 4 will give you 8 milliequivalents. That means how much H2SO4 reacted with ammonia is 8. Now put the value there. It is 8 upon 1000, 8 upon 1000 into 14 upon weight of the organic compound 0.2 into 100. That finally gives you the answer of the percentage of nitrogen, right? Then information about that this method cannot be applicable for the compounds which contain nitrogen in nitro group or azo group or in ring structures like pyridine, because that nitrogen cannot be converted to ammonium sulfate, right? And if it is not converted to ammonium sulfate, we are not going to get ammonia for further reaction with H2SO4. Now next is estimation for halogens. Here we take the organic compound, add HNO3 plus AgNO3 in that one, and in short finally halogen comes out as silver halide, AgX. So by using this method, which is in which tube? A sealed glass tube known as Carius tube. In that tube we put organic compound, oxidize it with HNO3, then add AgNO3, and finally our compound comes out, a precipitate is AgX. That can be AgCl, AgBr, AgI, and then we can find out the percentage of the halogen. How? Simple mole concept method. Whatever is the weight of the precipitate divided by the molecular mass of the precipitate, and then whatever are the moles of AgX will be also moles of halogen, and then if we have moles of halogen multiplied by the moles of multiplied by the molar mass of halogen, and this term is basically what? This complete term. This term is mass of halogen divided by weight of organic compound into 100. So simple mole concept it is there. If you know the precipitate AgCl or AgBr mass given in the question, divide by the molar mass of the precipitate AgCl or AgBr. This will be the moles of precipitate, multiply by it the atomic mass of the halogen, because we know whatever are the moles of AgCl will also be the moles of Cl. For example, percentage of Cl, it will be weight of AgCl divided by its atomic molecular mass or formula mass. This term will be the moles of AgCl. This will also be the moles of Cl. That is why multiply that one with the atomic mass of Cl, and this term is the mass of Cl divided by the weight of the organic compound. Similarly, percentage of Br is question, in the question you will get the mass of AgBr. These are less relevant questions, that's why no need to do, I'm not putting any numericals there, you can directly solve them, they are very easy questions. Weight of AgBr upon its molecular mass, this will be the moles of AgBr, this will also be the moles of Br multiplied by the atomic mass of Br, and this is the term which is weight of the Br upon weight of the organic compound into 100. So this will be in which tube? In the Carius tube. Similarly, next two, for sulfur and for phosphorus, they also are estimated in Carius tube. Now in for sulfur organic compound with HNO3, or we take sodium peroxide, it converts that sulfur into sulfuric acid, and then we add excess of barium chloride water, and we get here finally precipitate of BaSO4. From this PPT we can estimate the percentage of sulfur. Whatever are the moles of barium sulfate will also be the moles of sulfur, and then multiplied by the atomic mass of sulfur, that is multiplied by the 32. Now you can see the formula, weight of BaSO4 which is given in the numerical divided by its molecular mass, and this term will also be the moles of sulfur multiplied by the atomic mass of sulfur, and this term now is mass of sulfur divided by weight of the organic compound into 100. Okay. Then next is percentage of phosphorus. So two terms are given in NCERT. One is estimation of phosphorus, we treat it with same method, Carius tube with HNO3, it forms phosphoric acid. Then one is if we add in that phosphoric acid ammonia and ammonium molybdate, then we get ammonium phosphomolybdate, which is I am mentioning here as APM, ammonium phosphomolybdate, and using that we are estimating the percentage. So here first, if it is ammonium phosphomolybdate, percentage of phosphorus will be what? In that molecule there is only one phosphorus, so whatever are the moles of this precipitate will also be the moles of phosphorus multiplied by the atomic mass of phosphorus will give you mass of phosphorus. So here directly using the values from the NCERT, this is weight which is given in the numerical, if it is given upon its molar mass, this term is number of moles of phosphorus also, and then multiplied by atomic mass of phosphorus, and this part will be mass of the phosphorus divided by the weight of the organic compound into 100. Another point given is that we can also add another method, or another precipitate given is we can also add magnesia mixture, which is giving a particular compound which is MgNH4PO4, and then on ignition that compound gives Mg2P2O7. This is used for the estimation that whatever is the precipitate of this divided by its molar mass. And now in this we know that there are two phosphorus molecules, so multiplied by 2 to get the moles of phosphorus. So here this will be the moles of phosphorus, this will be the moles of Mg2P2O7, multiplied by 2 you will get the moles of phosphorus multiplied by the atomic mass of phosphorus, that is 31, and this term becomes completely mass of phosphorus divided by the weight of organic compound, and then you will get the percentage of phosphorus. So these are the two different precipitates given. One is given with ammonium phosphomolybdate, that is one method. Another is given that it is after ignition, firstly with magnesia mixture a particular compound is formed which on ignition gives Mg2P2O7. Okay, so this is the part of the quantitative analysis. Now next is for estimation of oxygen. One way is that we can also subtract the composition of other elements from the 100%, like carbon, nitrogen we can eliminate, hydrogen we can subtract, and the remaining portion percentage of oxygen will be there. Or other way which is given in NCERT is the method in which the organic compound is passed or heated with stream of nitrogen gas. This reaction gives oxygen along with some other gases. Now this oxygen is passed through red hot coke. After this it converted to carbon monoxide. then that complete CO, carbon monoxide, is passed through warm I2O5, and this complete CO will finally oxidize to CO2 and iodine goes to I2. Okay? Now this is written here in the form of reaction that organic compound heating with nitrogen gives O2 plus other gaseous products. This O2 with red hot carbon, high temperature around 1100 degrees Celsius, gives carbon monoxide. This carbon monoxide, when passed with I2O5, passed through warm I2O5, gives CO2 plus I2. Now in this case, depending on the information, like if we know moles of I2 obtained, I2 evolved or CO2 liberated, we can easily find the moles of CO. And if we have moles of CO, that is completely coming from that. So if we have the moles of CO, we can also relate it to what are the moles of oxygen evolved. And if we have moles of O2, we can find the moles of one oxygen, and then we can find the percentage of the oxygen. So it depends, like in NCERT it is given with CO2, but we can also find out by using I2. Only thing is that this is the method given in NCERT, that's why we are doing it. Otherwise, the important part from this topic is either for the nitrogen, Dumas or Kjeldahl method. That is the most relevant, I think. So you can better practice these questions, but here we are doing how to estimate oxygen. Now, suppose weight of CO2 is x grams, right? So what are the moles of CO2? It will be x by 44 grams. Sorry, moles will be x by 44. Now if you have moles of CO2, it will also be equal to moles of carbon monoxide. Why? Because I have already written the balanced equation, right? So here x by 44 are the moles of CO2. That will also be the moles of CO. And if we have moles of CO, then half will be the moles of O2. That means x upon 44 into 1 by 2. These are the moles of oxygen, that is in the form of O2. Now if we find the moles of oxygen, single O, it will be what? If we have moles of O2, it will be double in the moles of oxygen. Double means here 2 into 1 by 2 x upon 44. That makes it simply x upon 44. These are the moles. Now if you have the moles of oxygen, single oxygen, then what will be the weight of oxygen? It will be x upon 44 into 16. So this is the mass of oxygen. So for finding out percentage of oxygen, weight of oxygen, which is 16 upon 44 into x, which is mass of CO2, which is given in the numerical, if numerical is asked, upon weight of the organic compound into 100. So that is the formula to find percentage or estimation of oxygen in the given organic compound.